Welcome back. In part 1, we categorized energy into 9 distinct forms, from kinetic to nuclear. But that taxonomy hides a crucial reality. Energy refuses to sit still. It is effectively useless to us. Imagine shivering next to a giant pile of wood. That timber is packed with energy, but simply sitting near it won't keep you warm. The energy is trapped. To get warm, you have to force a change. By igniting the wood, you trigger a chemical reaction that converts the stored chemical energy inside that timber into radiating heat energy. Energy performs work by constantly shifting between these states. These conversions happen organically all around us. When a ball rolls up a hill, its forward momentum, or kinetic energy, drains away. That energy is actively converted into potential energy, stored as the ball gains height. When the ball reaches the peak and rolls back down, the process reverses. The stored potential energy transforms back into kinetic energy, accelerating the ball toward the bottom. Fascinated. Biology relies on this same shifting principle. Plants act as natural energy converters through photosynthesis. They pull in light energy from the sun and package it into stored chemical energy, creating the food that sustains humans and animals. These continuous physical and biological transformations form the foundational baseline for all survival on Earth. We design specific machines to isolate and force these natural transitions for our own use, turning them into dedicated transformation chambers. Look at the solar cells mounted on modern streetlights. They act as translators, absorbing incoming light energy and converting it into the electrical energy needed to illuminate the bulb. This steam engine diagram maps a multi-step translation. Chemical energy in the coal fire boils the water above it, creating heat energy as steam. This expands to push a mechanical piston, delivering an output of kinetic energy. We engineer these conversions for recreation, too. A loudspeaker takes electrical energy and turns it into sound energy. A remote-controlled toy car pulls stored chemical energy from a battery to create immediate kinetic movement across the floor. For daily utility, conversions are everywhere. Light bulbs turn electrical to light. Electric fans turn electrical to kinetic. Electromagnets turn it into magnetic energy. And phone chargers convert electrical back into chemical energy inside a battery. Our modern technological infrastructure functions as a network of devices built to route and convert energy between these various forms. Within a typical home, the television is constantly transforming electrical energy into visible light and sound. A telephone converts vocal sound into electrical signals, sends them across a wire, and translates them back into sound on the other end. In the kitchen, geysers and toasters take that same electrical current and force it through high-resistance wires to generate heat. In the laundry room, washing machines and grinders take electrical energy and spin a motor, turning it into mechanical energy. This dashboard matrix maps out the flow. Discharging batteries push chemical energy into electrical, while windmills do the reverse, catching mechanical wind power to generate electricity. Every single appliance you plug into a wall acts as a localized energy translator. All of these individual machines and natural processes operate under a single overarching mathematical rule, the law of conservation of energy. The rule states that energy can neither be created nor destroyed. It can only be changed or transformed from one form into another. At peak point A, potential energy is maximum, kinetic is 0, total energy is E. Dropping to point B, potential zeroes out, kinetic maxes to E, total stays E. Rising up loop C, potential becomes E1, kinetic decreases equally. Total energy remains locked at E. Throughout the entire ride, the numbers never cheat. Not a single drop of energy is ever lost or created. The universe keeps a perfectly balanced ledger. We scale these exact same physical laws up to power our civilization using hydroelectric dams. Millions of gallons of water stored high behind a concrete wall hold immense potential energy. When the floodgates open, the water rushes down the spillway, converting that stored potential into massive amounts of kinetic energy. That moving water slams into a turbine, spinning it to create mechanical energy. Finally, a generator attached to the turbine converts that mechanical rotation into the electrical energy that powers the grid. From roller coaster loops to massive concrete dams, every calorie of energy is accounted for as it moves through these transitions. which leaves a question for you to solve. If energy can never be destroyed, what happens to the kinetic energy of a speeding car when the driver slams on the brakes and forces it to a complete stop? Where does that energy go? Let me know your answers in the comments below. If you enjoyed this two-part series, hit the like button, subscribe to the channel, and ring the bell so you don't miss our next deep dive. Stay curious.